Hello students, today in this lecture we are going to learn about isotonicity and different methods used for preparation of isotonic solutions. First of all, we will see what is isotonicity and why it is required in drug formation. The tonicity term refers to the osmotic pressure exerted by a solution due to the solutes or dissolved solids present. Physiological fluids exert an osmotic pressure equal to that of normal saline or 0.9% weight by volume sodium chloride solution. That means 0.9% weight by volume sodium chloride can cause freezing point depression by 0.52 degrees Celsius. If drug solution contains greater amount of solutes than physiological fluid exerts greater osmotic pressure, this is called as hypertonic solution. If drug solution contains lesser amount of solutes than physiological fluid exerts lower osmotic pressure, this is called as hypotonic solution. If two solutions exert same osmotic pressure, then it is known as isotonic solutions. But why the drug formulations, especially in case of injections and ophthalmic preparations, needed to be isotonic with body fluid? Because when we inject or administer hypotonic solution in a human body, it causes swelling of red blood cells, and red blood cells could even burst, which is known as hemolysis. Another, when we inject or administer hypertonic solution in a human body, it causes shrinkage of red blood cells. Due to these reasons, the drug formulation needed to be isotonic with body fluid. There are several methods for adjusting tonicity of aqueous solution. The most prominent methods are: first one, freezing point depression method; second one, sodium chloride equivalent method; third one, molecular concentration method; fourth one, isotonic solution V value method; fifth one, molecular weight method. In today's session, we are going to study first two methods. Those are freezing point depression method and sodium chloride equivalent method. Let's discuss freezing point depression method first. This method is based on the principle of equalization of freezing point or D value of blood, that is our body fluid, with drug formulation by adding different tonicity adjusting agents. The freezing point of blood and other body fluids is minus 0.52 degrees Celsius. The preparation containing drug and additives must have equal freezing point. So, the equation used for calculation of percentage amount of tonicity adjusting agent to be added for making a solution isotonic with a body fluid is given as freezing point of body fluid minus freezing point of drug solution of a particular strength divided by freezing point of tonicity adjusting agent. The freezing point, that is the D value of commonly used tonicity adjusting substances of their 1% weight by volume solutions, are given in this table. Let's make this method better understood by calculating this example. In this example, we have to prepare 0.5% weight by volume potassium chloride injection. The freezing point of 1% weight by volume potassium chloride is 0.439 and freezing point of 1% weight by volume sodium chloride is 0.576 as given. Here, sodium chloride is used as tonicity adjusting substance. So going towards a solution, first of all we have to calculate freezing point of 0.5% weight by volume potassium chloride, which is a drug solution. We have freezing point of 1% potassium chloride solution, that is 0.439, which is already given in example. So freezing point of 0.5% weight by volume potassium chloride solution is calculated by multiplying percentage weight by volume with its freezing point. So the freezing point of 0.5% weight by volume potassium chloride is equal to 0.5 multiplied by 0.439, that gives the value, that is 0.2195. Now for calculating a percentage amount of sodium chloride needed to be added for making 0.5% weight by volume potassium chloride injection, that is isotonic with body fluid, by using the equation as we have already studied above, that equals to freezing point of body fluid minus freezing point of drug solution of a particular strength divided by freezing point of tonicity adjusting substance. Now putting the values in this equation is equal to 0.52 minus 0.2195 divided by 0.576, we get the value, that is 0.52%, which means we have to add 0.52% weight by volume of sodium chloride to make 0.5% weight by volume of potassium chloride to make isotonic with body fluid. We can make better understood this method by taking another one example. In this second example, we have to make isotonic solution of given dexamethasone sodium phosphate injection. The standard freezing point depression value for 0.5% weight by volume dexamethasone sodium phosphate is 0.05 degrees Celsius. And freezing point of 1% sodium chloride is 0.576 as given in formula. The formula given in example is dexamethasone sodium phosphate 0.1% and purified water 30 ml. This formula that is used for preparation of dexamethasone sodium phosphate injection. Now going towards the solution of this example. First of all, we have to calculate freezing point of given drug solution. It is 0.1% weight by volume dexamethasone sodium phosphate. Here, the given freezing point depression value for 0.5% weight by volume dexamethasone sodium phosphate is 0.05. So, the freezing point of 0.1% weight by volume dexamethasone sodium phosphate, that is equal to 0.1 multiplied by 0.05 divided by 0.5, that is equals to 0.01. So now the freezing point of 0.1% weight by volume dexamethasone sodium phosphate is 0.01. Now As per discussed in earlier example, for calculating percentage amount of sodium chloride needed to be added for making 0.1 percentage weight by volume dexamethasone sodium phosphate isotonic with body fluid by using equation, that is freezing point of body fluid minus freezing point of drug solution divided by the freezing point of tonicity adjusting agent, that is sodium chloride. By putting the values in above mentioned equation, we will get 0.52 minus 0.01 divided by 0.576, that gives 0.885 percentage, which means we have to add 0.885 percentage weight by volume sodium chloride to make 0.1 percentage weight by volume dexamethasone sodium phosphate isotonic with body fluid, which also means that for 100 ml of injection 885 mg sodium chloride is needed. As per question, for 30 ml injection, the amount of sodium chloride needed is equals to 30 ml multiplied by 885 milligrams divided by 100 ml. So, we get 265 milligram of sodium chloride, which is needed to make 30 ml. 0.1 percentage dexamethasone sodium phosphate injection to become isotonic with body fluid. Now, alternatively, we can use another tonicity adjusting substance instead of sodium chloride, such as dextrose or any other tonicity adjusting substances as mentioned in this table. Let's solve this example by taking dextrose as an tonicity adjusting substance. Let's use 1% weight by volume dextrose as tonicity adjusting substance. Freezing point of 1% weight by volume dextrose solution is 0.091. As per discussed earlier, let's calculate the percentage amount of dextrose needed to be added for making a 0.1 percentage weight by volume dexamethasone sodium phosphate, that is isotonic with body fluid, by using the equation, that is freezing point of body fluid minus freezing point of a drug solution. Here the drug solution, that is dexamethasone sodium phosphate, divided by the freezing point of tonicity adjusting agent. Here we are using a dextrose as a tonicity adjusting substance. Now placing the values into the above equation, 0.52 minus 0.01 divided by 0.091 is equals to 0.560 percentage of dextrose. Here the values placed directly. So for 100 ml solution, 5.60 gram dextrose is required. So for 30 ml of solution, the required amount of dextrose can be calculated as 5.60 multiplied by 30 ml divided by the 100 ml. That gives 1.68 gram of dextrose. Thus, 1.68 gram of dextrose is needed for 30 ml 1% dexamethasone sodium phosphate injection to become isotonic with body fluid. Now, let's discuss about next method for preparation of isotonic solution, that is sodium chloride equivalent method. This method is modification of freezing point depression method, in which the ratio of freezing point depression produced by solution of medicament and freezing point depressed by sodium chloride of a same strength is calculated as sodium chloride equivalent, that is ENaCl value of that medicament. For example, sodium chloride equivalent of 1% weight by volume potassium chloride is calculated as freezing point depression of medicament divided by freezing point depression of sodium chloride. Freezing point depression of 1% weight by volume potassium chloride is 0.439 and freezing point depression of 1% weight by volume sodium chloride is 0.576. So, by taking a ratios that equals to 0.439 divided by 0.576, we get 0.76, that is the ENaCl value of 1% potassium chloride solution. Now, in this method, the percentage of sodium chloride required for adjustment to isotonicity can be calculated using the following formula. Percentage NaCl required equals to 0.9 minus percentage strength of drug solution multiplied by equivalent NaCl value of drug. ENaCl value of 1% weight by volume solution of some drug substances are mentioned in this table. As we have calculated ENaCl value, that is sodium chloride equivalent value of potassium chloride, that is 0.76, is mentioned in this table. So, we can directly use this ENaCl value for calculation purpose. Let's make this method better understood by calculating one example. In this example, we have to calculate the amount of sodium chloride used for compounding 5 ml of eye drop that contains 2% weight by volume pilocarpine nitrate. Now, going towards the solution of this example, we will use the formula percentage NaCl that equals to 0.9 minus percentage strength of drug solution multiplied by ENaCl value of drug. Here, percentage strength of drug solution is 2% weight by volume of pilocarpine nitrate and ENaCl value of pilocarpine nitrate is 0.22. So, now placing the values in this equation, we get 0.9 minus 2 multiplied by 0.22, that equals to 0.46% NaCl, which means 0.46 grams or 460 milligrams of NaCl is needed for preparation of 100 ml 2% weight by volume of pilocarpine nitrate eye drops. So for 5 ml of pilocarpine nitrate eye drops, the amount of sodium chloride needed is equals to 5 multiplied by 460 milligrams divided by 100 ml. So we get 23 milligram sodium chloride. Thus, 23 milligrams of sodium chloride is needed for 5 ml of 2% weight by volume pilocarpine nitrate eye drops to make it isotonic. Now, going towards the next example. In this example, we have to make dexamethasone sodium phosphate injection isotonic from given formula. The given standard sodium chloride equivalent value for 0.5% weight by volume dexamethasone sodium phosphate is 0.18 grams. In the formula, the dexamethasone sodium phosphate is 0.1% weight by volume, and given NaCl value of dexamethasone sodium phosphate is 0.18 grams, which is for 0.5% weight by volume solution. So, first of all, we have to find eNaCl value of 0.1% weight by volume dexamethasone sodium phosphate, which is found by 0.1 multiplied by 0.18 divided by 0.5. That gives 0.036 grams. That is for 0.1% weight by volume dexamethasone sodium phosphate solution. Now, by using the equation percentage NaCl is equals to 0.9 minus percentage strength of drug solution multiplied by eNaCl, that is equivalent NaCl value. Now putting the values in this equation, we get 0.9 minus 0.1 multiplied by 0.036. That gives 0.8964%, which means for 100 ml 0.1% weight by volume dexamethasone sodium phosphate 896 mg of NaCl is needed. So, for as per question, we have to prepare 30 ml of 0.1% dexamethasone sodium phosphate injection. The amount of NaCl required that can be calculated by 30 ml multiplied by 896 mg divided by 100 ml. That gives 268 milligrams. Thus, 268 milligram sodium chloride is needed for 30 ml of 0.1% dexamethasone sodium phosphate to make it isotonic. In next session, we will see the another three methods for calculation of isotonic solutions.